Okay, guys, I hope that you have listened now the first video that I have uploaded, and you have now background of the oscilloscope and the function generator. This experiment is a bit different from the previous one, because previous all the experiments actually that now we are moving towards the AC sources and AC circuits. Um, Previously we have DC voltages and DC current, so we were using DC voltmeter, DC ammeter, and also we were using a multimeter to to measure these the voltages and currents. Okay, so here the difference is that we will have AC source, and then we have to measure that AC source. And okay, before going deep into that experiment, um, actually I wanted to let you know that the version that you can see here is like 14.2, which is the latest version. However, if you are close to that latest version like 12 or something, it's okay. However, if you are using the older version that is in the lab, you might, the interface is different and also some components are different. But when I uploaded, when I announced actually the that if anybody is using the older version, nobody replied to me. So I assume that nobody is using the older version. Everyone has the latest version. Now the thing is that this must be installed in your computer, because next week we might have a quiz, maybe for because we haven't took any quiz up till now, and definitely we have to take at least 2 to 3 quizzes. So maybe in the next 3 weeks, actually maybe we have like quizzes for every week. I will announce this later on, but let's start doing that. How you can now implement the AC circuits in this multisim. First, I just wanted to give some brief about how you can find the components here. Some of them are different, and definitely the icons are different. So let's go one by one. For example, if I wanted to find the basic, this is like I'm just giving you the brief introduction before going into the AC analysis or AC circuits. Like for example, if I want to find a resistor, so this is the resistor icon. This is a bit different. Okay, a bit different in a sense that you have a lot of things here come up, and you can see the resistor here. So you have to click this one, and the value, there's a lot of values. Whatever value you want, you can just select, like for example 100 ohms, or maybe 1000 ohms, or 1 kilo ohms, or whatever, 1k. Okay, so you can press OK, you can press OK. So this will come up, and the dialog box will again open. So you have to just close it, and the resistor is there. So this is the first thing, how to find. This is a bit different than the previous version. Similarly, if you want to find, for example, let me show you this. This should be in the sources icon. In sources icon, either you can find ground or the current voltage source. So let's first found the ground. Just find, this is the ground, and I can just place it here. Okay, and then either I close it, or if I need another component I can do it. Okay, now for the voltage and current, this is like, because I'm just showing you that how you can find. So either you can find the AC, you see AC voltage, AC current, or this DC current or DC voltage. But DC voltage here it's not there. So let's talk about the DC sources. So we have, if I write DC here, I will get all these DC power. Definitely we don't need it. DC current sometimes yes we need it. So let's check it out. And also let's see what's the difference between DC interactive current and DC interactive voltage. Make sure that there is no DC voltage here. Okay, so what's the difference? Now this is the same as we did previously, like whatever I want, maybe 10 ampere, so I can do that. So this is 10 ampere is there. Okay, now for the DC interactive, this is DC interactive. What it means that this is just an interactive type of display. Like for example, this is a bar. I can set any value from 0 ampere to 5 milliampere. However, for example, if I need 10 milliampere, what should I do? I just click it there and set the maximum value to 10. Okay, so now it will give me from 0 to 10. So any value, for example 7 milliampere I need, I can place it. So you can place any of this one or this one. For the DC voltage, because we don't have simple DC voltage, we only have the DC interactive. So here you can just set the bar to any value. The maximum is now 10 volts. However, I can make it 100 if I want 100. Okay, and I can, maybe if I need 50, I can just set it there, 50. Okay, and then I can connect the same way as we did for the previous. This is just to give you some brief explanation about that, what is the difference between this and that. Okay, now this version and the previous version. Now here I can find, this is the indicator icon. Okay, so indicator, so if you want to place ammeter or wattmeter, you can place it. This was in experiment number 2. Also multimeter, I can find it here. This icon is almost same, so I can place it here like the one that I did it before. Okay, so I can run it from here, and with 0 errors. You can see the the good and maybe the bad. Both things are that even if you have error, you can run, and it will ask you that there's error, and you want to run it or not. So if you place there yes, it will run, but it might not give you the good results. In the previous version, the older version, the problem was that um, if you have error, you cannot run the multisim. Okay, let's stop this and go back to remove all of this stuff. Okay, now I will just show you how you can do the AC analysis. For this experiment, we will just generate a AC waveform and analyze it, and there is no circuit involved. The circuit will be in the next experiment. Okay, so we have to find the function generator and oscilloscope. Two things we have, we must need, we need it here. Okay, so this is the function generator, and let me zoom further. Okay, where is the, okay, so this is the oscilloscope, right? Now here I will generate any waveform with specific frequency, specific peak voltage. Okay, or and also the what else we have, okay, the amplitude, and yes, and also we have some DC offset. We will talk about this later on, and also specific shape. So AC, we have either specific shapes like sinusoidal, triangular, rectangular, with specific frequency. Duty cycle, don't need it. Amplitude and offset. Amplitude either peak to peak or peak. Here it's peak, so peak will be from 0 to the peak. Peak to peak will be from negative cycle to the positive cycle. Okay, from like this cycle to here. Anyhow, I will show you later on. Okay, so this is my oscilloscope. It will show you the waveform that I will generate. So make important thing here is the connections. So I will connect the positive with the positive, uh, and okay, and then I need a ground. So I will just have a ground here. Okay, and place it here, and it must be connected. Actually here I need two grounds, so I will place it two. Common will be ground and negative will be open. Okay, if you place a negative, it will actually kind of add the positive negative terminal. So for example, if you are generated, for example, 10 volts peak, it will give you 20 volts. Okay, so that's why we don't need to do that, and negative should be ground. Okay, and make sure that we have now here two channels. It means that I can connect two function generator here, and in the screen the two waveform will be displayed. Okay, so I think that's it. Let's start it. I hope it's run, is 0 error. Okay, now you can see that there's some kind of movie going on here, because definitely it's changing, huh? So the first thing that I have to do is to click on single. That will show you the single frame. Okay, so it's a single frame, it's changing. But however, the problem is this oscilloscope is just like a graph. The if you are, you know, the divisions are very less, then it must be like a big graph. Now if you can see that the graph is going like this, it means that it's not fit in my graph here. The curve is like going outside the graph. So let me now there are two divisions, either here the vertical and the horizontal. Okay, so let's play with the horizontal. Now here if you see, this is the time base. This is set to 10 millisecond per division. Per division means this big circle, this one. Okay, so it means that this is actually 10 millisecond per division, but my waveform doesn't fit in this screen. So what I need to do to shrink it, definitely it's just like a graph in your, you know, in your notebook. So I have to increase this scale. Okay, so I can say, for example, 20. If you can see, it's like coming up, and I can see the one cycle of the waveform. Even you can see more. Okay, fine. And similarly, this is the the vertical scale, which is 5 volts per division. So this whole box is 5 volts, this is 5 volts, this is 5 volts. Okay, and for example, if I make it less, it definitely goes out of this graph, so I have to make it according to my requirement. Okay, this is the first. Now let's see what I have generated. I have generated 1 hertz frequency with amplitude 10 volts peak and offset 0. So let's check what this is, the oscilloscope. Let's see what I am getting. If you see the amplitude, let's calculate the amplitude. I told you before that the V peak is actually from 0 to this. This is V peak. When we talk about the V peak to peak, it will be from this peak to this peak. Okay, so for example, if V peak is here 10 volts, V peak to peak will be 20 volts. Okay, but here I am talking about the peak, so it is 10. So let's see it's 10 or not. Here we have 5 volts per division. So this is 5 volts and this is 5 volts. So 5 plus 5, 10. It means that this is 10 volts. It is giving the correct value. Now see the frequency, 1 hertz. I can check my one cycle here. Okay, this is one cycle, and I will see what is frequency. Frequency is just a number of cycles per second, or the time period, one by time period. So the time period here is this, and this is equal to, if I say 200 milliseconds, one box, and these are 1 2 3 4 5. So this whole become 5 multiplied by 200, which is 1000 milliseconds, or equal to 1 second. So it means that this is 1 second, and if I just invert it to get the frequency to, I will get the 1 hertz. Okay, which is correct. Now the other thing, then if I, okay, there are questions in the reports, like if you increase or decrease the time scale, what is happening. So you can say that, okay, shrinks or it expands. Similarly in the higher scale, I mean the voltage scale, also it either expands or contracts horizontally or vertically, depending upon the which scale you are changing. Okay, now there is DC offset. DC offset is just like, you know, adding a DC voltage to an AC voltage. For example, if I set it to 2, what will happen? Okay, 2, what will happen? Okay, here also I can set the V peak to peak. No, it's not, there's not V peak to, in the older version it was there. Okay, anyhow, okay, so offset is 2. It means that 2 volts, a constant 2 volts will be added to this one. Now if you see, it starts from 0. So if I add 2 volts here, it will shift up to 2 volts. Like this point is 0, it will go to 2. So it must shift to 2 volts. However, if I change it but it didn't shift it, why? Because of this scale. Okay, if you place it at DC, it will not allow DC, but if you place it at AC, it must allow it. Okay, so nothing changed here for AC or DC. Fine. Now the thing is that why it's not changing is that we have to run it again. However, we have to just uh, see that why it's AC and DC. What do you mean by this? AC means that it will just, when you press AC, it means that it will block any DC. Okay, if even if you set the value, there's nothing change will occur. However, if you have a DC, it must change. However, to make it change, you have to run it again here, and here if you see, this is like shifted up. Okay, you see this, first it was here and here between this and this line, now it's shifted up. Now to check that, okay, there's another thing, that are these cursors. So you can check the value anywhere, and you can see the peak here. This cursor reading comes here, this one is the first cursor, you see here. Okay, the other is 0, so the other cursor is this one. So if you can, if you want very precise reading, you can just place it anywhere, and this will show you the exact time here, which is this thing, milliseconds, and the amplitude, which is this. So if you can see, this is now around like 12, it should be 12. Let me see here, like around 12 is, must be 12, but yeah. Okay, so it's around 12 here. Okay, so you can check, previously it was, okay, previously it was 10. Okay, around 10. Yes, you can check this, and this, the last scale, is just the difference between the first two. um, like for example, if you want to measure peak to peak, you can measure the peak to peak as well from here. Like for example, one negative and one positive peak, this must be 20, yeah. So this is like around 20, like one peak to another peak. Okay, so I think this is it. The other questions you have to answer, and you have to upload your, there's no pre-lab for this, so you have to just upload your lab reports answering all the questions. Next time we will have a quiz for that. For I will announce it, that which experiments are included, and it will be on directly on the blackboard. So thanks, and I will also, if you can reach me either email, or if I am online, you can call me on online. Okay. Thank you. Thanks a lot for your for watching me. All the best.